At 6,721 meters on a Chilean volcano, a Porsche 911 is running on roughly half its horsepower because the atmosphere is too thin to deliver the rest. Thousands of miles away, a Bentley Continental GT moves through Russian wilderness not on wheels, but on tank tracks. These are two of the most refined machines ever built for smooth pavement, now surviving terrain that would defeat purpose-built off-roaders. Factory specifications say none of this should work. The real question is not whether exotic cars can defy their limits, it is what happens to the engineering, the physics, and the reputations staked on finding out. Ramon Dumas stood on the edge of the Atacama, staring up at Ojos del Salado's battered slopes. For him, the Porsche project was never about comfort or luxury. It was about pushing a machine, and himself, to a place no wheeled vehicle had gone. The goal was clear: break the altitude record, not for the sake of a headline, but to see how far clever engineering and relentless determination could carry a car built for the Autobahn into the thin air of the Andes. Dumas, a seasoned endurance racer, brought the mindset of a climber to the cockpit, calculating risks, trusting his team's modifications, and accepting that above 6,000 meters, every decision could be the difference between progress and failure. Half a world away, a group of Russian fabricators eyed a different kind of challenge. Their Bentley Continental GT, stripped of its original wheels and fitted with tank tracks, was a statement against the ordinary. For these builders, it was not about records or recognition. It was about proving that even the most extravagant Grand Tourer could become a force in the wild if you had the nerve to tear it apart and rebuild it for mud, snow, and the unknown. Swapping in a Toyota V8, welding reinforcements across the chassis, and improvising solutions as each new problem appeared, they treated the Bentley as a blank canvas for mechanical experimentation. On opposite ends of the spectrum, precision planning on a Volcano and improvisation in the Russian wilderness, these two projects reveal what happens when personal ambition collides with the limits of design. Whether chasing a number on an altimeter or the thrill of invention, both teams saw possibility where others saw boundaries. In their hands, exotic cars became test beds for the kind of ingenuity that refuses to accept what is impossible on paper. Porsche and Bentley stand as more than just car makers. They are living symbols of what automotive excellence means on the world stage. For Porsche, decades of motorsport victories, including Le Mans, Dakar, and Nürburgring, have cemented a reputation for relentless precision and speed. Every 911 carries the weight of that racing pedigree, engineered to tame circuits and autobahns with equal confidence. To modify such a machine for a volcanic ascent is to gamble with a legacy shaped by generations of engineers and drivers, where any failure in the wild risks more than just parts or pride. It calls into question the very identity of the brand. Bentley, on the other hand, has always traded in a different kind of prestige. The Continental GT is the embodiment of British luxury, hand-stitched leather, and silent, effortless power. It is a car built for grand tours, not grueling off-road slogs. Transforming it into a tracked behemoth means dismantling the very qualities that made it an icon: the smoothness, the refinement, the assurance that every detail serves comfort and style. Each cut of the welder's torch and every new bolt driven into the chassis is a direct challenge to the values Bentley has spent a century perfecting. When these brands become the canvas for extreme experimentation, the stakes stretch far beyond technical success or failure. The risk is reputational, emotional, even existential. Porsche's name is on every ascent, and Bentley's badge rides every muddy trail. Pushing these machines into hostile territory is not just a test of engineering, it is a test of what these brands mean and what they are willing to become in a world where the definition of greatness is always shifting. On the workshop floor, the Porsche 911 Carrera 4S began its transformation from Autobahn athlete to volcanic explorer with a simple but radical premise: keep the heart of the car untouched, but rebuild its legs and armor for a world that wanted to chew it up. The standard 911 sits just 120 millimeters above the road, a height perfect for slicing through corners, but a liability in a landscape littered with jagged lava and boulders the size of suitcases. The solution came in the form of custom portal axles, a technology borrowed from military vehicles and extreme off-roaders. By raising the hub above the axle centerline, these portals delivered an astounding 350 millimeters of ground clearance, nearly triple the stock figure. Without disturbing the car's drivetrain geometry, the result was a stance that could float over volcanic scree while keeping all four wheels planted for maximum traction. The next challenge, protection. At 6,700 meters, every rock is a potential wrecking ball. Underneath, aramid fiber panels, akin to Kevlar, formed a lightweight but nearly unbreakable shield. This material, chosen for its high tensile strength and resistance to abrasion, absorbed impacts that would have punctured steel or aluminum. The panels were fitted flush to the underbody, preserving aerodynamics while deflecting razor-sharp debris. Each mounting point was selected for structural integrity, distributing force across the chassis and sparing critical components like the oil pan and transmission tunnel. Tire selection became an exercise in compromise. The team chose 310 mm wide BFGoodrich off-road tires, sacrificing some of the 911's signature road feel for flotation and grip on loose ash and pumice. The tires' deep tread and flexible sidewalls allowed them to deform over obstacles, while their width spread the car's weight, minimizing sinkage in soft ground. The pressures were tuned for altitude, balancing sidewall flex against the risk of bead unseating in thin air. Suspension links and geometry were reworked to match the new ride height and wheel travel. A motorsport-derived warp connector system ensured that even when one wheel dove into a crater or scrambled up a boulder, the others stayed in contact with the terrain. The stock all-wheel drive system and 7-speed manual transmission remained untouched, relying on Porsche's original engineering to manage torque and power, proof that the core mechanical DNA of the 911 could adapt to the most unforgiving environments with only targeted changes. Every weld, bracket, and bolt told the story of a workshop where craftsmanship met necessity and where the limits of a supercar were redrawn by human hands. Long before dawn, Romain Dumas strapped into the cockpit of the modified Porsche 911, the digital clock reading 3:30 in the morning. The base camp was already bitterly cold, with the thermometer well below zero and the wind scraping across the plateau. Every breath felt thin, even with supplemental oxygen. Above, Ojos del Salado's slopes glowed faintly in the moonlight, a jagged path of scree, ash, and ice waiting to test both car and driver. The first kilometers passed over loose volcanic gravel, the portal axles, and 350 millimeters of ground clearance, allowing the Porsche to glide over obstacles that would have crippled a stock 911. As the team climbed higher, the air pressure dropped to just 43% of sea level. The engine's turbochargers, left untouched by the engineers, relied on Porsche's factory boost control to compensate for the thinning oxygen. The car's electronics quietly adjusted fuel and ignition on the fly, squeezing what power they could from each intake stroke. Despite the altitude, the 3.0-liter flat six kept pulling, down on horsepower, but still responsive enough to claw up slopes steeper than 40 degrees. By mid-morning, the temperature plunged to minus 30 degrees Celsius. The aramid underbody panels deflected sharp stones and frozen debris, each impact echoing through the cabin. The tires, chosen for their width and flexible sidewalls, deformed over jagged rocks and soft patches of pumice, keeping the car floating rather than digging in. Tire pressures were checked and rechecked, set low enough to maximize grip, but high enough to avoid losing a bead in the thin air. Every pit stop was a calculation. How much heat was left in the brakes, how much fuel burned by the struggling engine, how much oxygen left for the driver. Progress slowed above 6,000 meters, the air thinned further, sapping both human and machine. Dumas's reactions dulled, judgment required constant vigilance. The car's suspension, with its motorsport-derived warp connector, kept the wheels in contact with the shifting surface. On one exposed ridge, a misjudged line could have ended the attempt. Dumas chose a slower crawl, letting the all-wheel drive and portal axles do the work. The ascent became a series of small battles over boulders, through patches of wind-blown ice, across slopes where the car's own weight threatened to drag it sideways. At 3:58 in the afternoon, after more than 12 hours of grinding upward, the Porsche crested 6,721 meters. The onboard instruments confirmed the record. The car's modifications had done their job. The engine never stalled, the protection held, and the tires kept their grip. But the true test had been in the choices. Each compromise, each adaptation, each moment where the original design met the raw, unpredictable physics of the Volcano. In that thin, freezing air, the 911's mechanical DNA proved it could do more than anyone had imagined. On the Russian workshop floor, the Bentley Continental GT's transformation into the Ultratank began with a single audacious question. How do you turn a grand tourer into a machine that can float over deep mud and snow? The answer started at ground level. The car's original wheels and suspension were stripped away, replaced by a pair of track assemblies stretching nearly the full length of the car's body. Each track covered about 1 square meter of contact patch, distributing the Bentley's weight far more evenly than tires ever could. Where a standard tire might press down with 30 to 40 pounds per square inch, the tracks spread the load to a fraction of that, minimizing sinkage and letting the car glide where others would bog down. Mounting these tracks required more than just bolting on adapters. The team welded gusseted subframes to the Bentley's chassis, reinforcing the mounting points to handle the twisting forces that come from crawling over uneven ground. The factory suspension geometry was abandoned in favor of custom linkages designed to keep the tracks level, even as the car pitched and rolled. Every weld had to stand up to thousands of pounds of torque and shock loads from obstacles hidden beneath snow and muck. The heart of the Ultratank is a Toyota 5.8 engine, chosen for its reputation for reliability and its ability to deliver broad, flat torque at low revolutions per minute. Swapping out the Bentley's original power plant meant fabricating custom engine mounts, adapting the cooling system, and integrating new wiring harnesses. The V8's output fed into a modified transmission and transfer case, sending power to the track drive sprockets instead of axles. This change not only altered the car's character, but also demanded careful attention to drivetrain angles and stress points. Tracks generate more rolling resistance than wheels, and any misalignment could spell disaster in the field. To keep the luxury shell intact, the team worked around the Bentley's existing bodywork, trimming only where necessary to clear the massive tracks. The result was a machine that looked improbable but functioned as a single integrated unit. The original all-wheel drive system was sacrificed in favor of direct mechanical drive to the tracks, prioritizing durability over the computer-controlled finesse of the stock setup. The reinforced chassis, broad track footprint, and robust V8 combined to create a vehicle capable of clambering over obstacles that would stop most off-roaders cold. Every decision, each gusset welded, each gear ratio chosen, was a trade-off between preserving the Bentley's spirit and building something that could survive in the wild. The Ultratank is less a conversion than a reimagining, proof that even the most refined luxury car can be reborn as a brute force tool for conquering the unpredictable. The mechanical complexity and improvisation behind this build reveal just how far creative engineering can stretch the DNA of a car designed for silk roads, not frozen bogs. Mud and snow present their own set of rules, and the Ultratank's tank tracks rewrite the Bentley's relationship with the ground from the first rotation. On soft terrain, ground pressure drops dramatically. Where a standard tire might press into the earth at 200 to 300 kilopascals, the Ultratank's tracks spread the Bentley's weight over a much larger footprint, bringing effective ground pressure down to just 20 or 30 kilopascals. This difference is the line between sinking to the axles and gliding over a bog. In deep snow, the tracks float the 2-ton car with surprising ease, letting it move where most SUVs would dig in and stall. But every gain comes with a cost. Steering, once a matter of gentle input and instant response, becomes a physical negotiation. The Ultratank's tracks are designed for forward momentum, not finesse. Turning the car requires differential braking, slowing one track to pivot the body. The steering arc is limited, and tight maneuvers demand patience and planning. In a forest or on a narrow trail, the Bentley's long wheelbase and wide tracks challenge the driver's sense of space. The car can pivot in place, but not without a fight from the mechanicals. Driver feedback from the first field test tells a story of brute force and constant compromise. The Toyota 5.8 delivers steady torque, but the drivetrain endures punishing stress as the tracks bite into rutted earth. Each obstacle, tree root, frozen rut, or patch of sticky clay sends shockwaves up the reinforced subframes. Brake heat builds quickly, especially during prolonged turns or descents, as the system works overtime to control the tracks. In some runs, rotors glow red within minutes, forcing cooling pauses and adjustments to driving style. The original Bentley brakes, designed for high-speed stops on tarmac, now serve a different purpose, modulating the immense inertia of a tracked vehicle in unpredictable terrain. Inside the cabin, luxury takes a back seat to survival. The ride is noisy, every vibration amplified by the direct connection between the tracks and the chassis. Mud cakes the lower bodywork, and the suspension's travel is limited by the sheer size of the track assemblies. Yet the Ultratank persists, clawing its way through conditions that would defeat most purpose-built off-roaders. The conversion exposes the Bentley's hidden strengths, stiff structure, ample power, and a willingness to be reimagined. But it also lays bare the limits, steering precision, brake endurance, and the human cost of piloting a grand tourer far from its element. In these moments, the Ultratank is not just a demonstration of mechanical possibility, but a living experiment in what happens when luxury engineering meets the wild, and neither comes away unchanged. At 6,700 meters, the Porsche's turbocharged flat-six faced air so thin that atmospheric pressure dropped to just 43% of sea level. Combustion physics dictated that even with forced induction, the engine could only retain about 55% of its rated power, roughly half the oxygen, half the energy, but still enough to keep climbing. The car's electronics constantly recalibrated fuel and ignition, squeezing every usable joule from each intake stroke. Meanwhile, the Bentley Ultratank tackled a different frontier: ground pressure. Swapping tires for tank tracks multiplied the contact area by a factor of 10, dropping ground pressure to 20 or 30 kilopascals, less than a human footstep. Where the Porsche relied on wide, low-pressure tires and portal axles to float over volcanic scree, the Ultratank's tracks let it glide across mud and snow that would swallow most vehicles whole. Both machines rewrote the rules of traction and power retention, each adapting to hostile terrain through a blend of physics and mechanical improvisation. Above 6,000 meters, the rules of adventure change. Helicopters struggle to reach these altitudes, with most rescue operations capped below 7,000 meters due to thin air and unpredictable winds. For the Porsche Ascent, every step required backup plans, including oxygen caches for the driver, spares for critical components, and strict protocols for fuel and shelter. The team's responsibility extended beyond engineering, and environmental permits demanded careful route planning to avoid damaging fragile volcanic terrain. Even with all precautions, the risks were personal and permanent. Hypoxia sharpened the need for constant monitoring as reaction times slowed and judgment blurred. Proof of achievement rested on the car's onboard instruments, but without independent GPS logs or third-party verification, the record's legitimacy relies on trust in the team's process. These feats push not only the limits of machines, but also the boundaries of what can be safely attempted, documented, and believed. Today, a Porsche 911 stands at 6,721 meters on Ojos del Salado, and a Bentley rolls on tank tracks through Siberian mud, not because they were designed to, but because engineering refused to accept limits. As climate, terrain, and ambition collide, luxury performance becomes a question of possibility, not pedigree. The frontier isn't where the road ends, it's wherever imagination dares to drive. What boundaries will you challenge next?